Dear friends, welcome to Gateway to Physics. This is AromaL. Today we are discussing about the capacitor and its capacitance when a dielectric slab is introduced between its plates. Here you can see a parallel plate capacitor having two plates A and B. They have given charge positive and negative charges, and the separation between these two plates is D. So a parallel plate capacitors having separation D between the plates, and we have introduced a dielectric slab of thickness T, and its dielectric constant is K, and this slab is X distance away from the plate A, and the plate area is capital A. So we have introduced a dielectric. You know what is a dielectric? Dielectrics are usually insulators, but when they are introduced in an electric field, they will get polarized and it will produce an electric field which is actually opposing the external electric field. So here you can see when we have charged these plates as positive and negative, an electric field is developed between these plates. Here let the electric field be E0, and the induced electric field inside the dielectric be capital E. Then we know what is dielectric constant in terms of these electric fields. So dielectric constant is defined as the external electric field divided by the induced electric field. Actually, it is a reduced electric field developed inside. You know what is all these things. Okay, so this dielectric constant K is equal to external electric field divided by the reduced electric field developed inside this insulating slab or dielectric. Now, let us calculate or find the capacitance due to the insertion of this dielectric slab. So, we know how to calculate this potential. Potential and electric field are related as V is equal to electric field into distance. Potential V is equal to electric field into separation. Okay, so in order to find the capacitance, we have the formula C is equal to charge Q divided by the total potential difference. Here we have to find the capacitance between these two plates A and B. So we have to divide charge by the total potential difference between the plates A and B. So there are so many regions between A and B. Look at here. Let us number, this is 1 and this side is 2 and it is 3 and this plate is 4. So the potential between the plates A and B is equal to potential between the surfaces 1 and 2, which means potential in this region, plus potential between 2 and 3. Potential between 2 and 3 plus potential between the surfaces 3 and 4. So that is equal to V3, 4. Now we have to find the value of all these potentials. So look at here, the potential in the region between 1 and 2, between the surfaces 1 and 2. That is, we have potential is equal to electric field into distance. What is the electric field here? That is E0, and the separation, that is X. So E0, X. Then plus in this region between 2 and 3, the electric field is E and the thickness is T. So potential can be written as E into T, plus the potential between the region 3 and 4. Potential between the region 3 and 4 is electric field and distance. What is the electric field here? This is also outside the dielectric slab. So the external field, that is E0. That is E0 in what is the thickness of this region? The thickness is total thickness D minus X plus T. So that is D minus X minus T. This is the thickness. So from here we can write that is E0 taking common, E0 into X plus D minus X minus T plus E into T. So this is the total potential difference. Now we have to relate this E0 and E. We have the relation E0 by E is equal to K. So instead of this E, we can write E0 divided by the dielectric constant K. So this equation becomes E0 into X, and X minus X get cancelled, that D minus T plus, instead of this E, we can write E0 by K. So that is E0 divided by K into T. Now taking E0 as common, E0 into D minus T plus T divided by K. So this is the total potential difference between the plates A and B. So in order to find this capacitance C is equal to total charge Q divided by the potential, that is E0 into D minus T plus T by K, where K is the dielectric constant. Okay, now we have what is the electric field between the two plates of a capacitor, or the E0. We have electric field E0 is equal to sigma divided by epsilon 0. What is sigma? Sigma is the surface charge density. So we can write capacitance C is equal to Q by, what is Q? Q means sigma into E. Sorry, sigma into area. Sigma A divided by, instead of E0 we can write sigma by epsilon 0. So that is sigma divided by epsilon 0, then the factor D minus T plus T by K. So here sigma and sigma get cancelled, then C is equal to A epsilon naught divided by D minus T plus T by K. So this is the capacitance when this dielectric slab of thickness T and dielectric constant K is introduced between these two plates A and B. So here there is no term of X. So what does it mean? Which means the position of this dielectric slab inside these plates is independent of this capacitance. So this capacitance is independent of this distance X. So whatever be the position of this dielectric slab in between these two plates, the capacitance is same, that is A epsilon 0 by D minus T plus T by K. So for NEET examination you have to remember only this point. We have a capacitor, then its capacitance C is equal to normally A epsilon naught divided by D. Okay, when we are introducing a dielectric slab of thickness T and dielectric constant K, this capacitance, what happens? That is A epsilon 0 divided by the actual equation A epsilon 0 divided by D. Here write A epsilon 0 by D, then subtract the thickness of the slab. Okay, subtract the thickness of the slab, that is T, then add a factor, that is thickness divided by dielectric constant of that slab. So this will be the capacitance. So how many dielectrics are there? No problem, we can use the same method. For example, in between these two plates we have two dielectric slabs. Their thickness are T1 and T2 and the dielectric constants are K1 and K2. So what will be the capacitance? It's easy. This capacitance C dash is equal to the normal equation A epsilon naught divided by D. Then subtract these thicknesses, minus T1 minus T2. Then add the factors, the thickness by its factor, T1 by K1 plus the second mate T2 divided by K2. So how many slabs between them? There is no problem, we can use the same method. Write the actual equation A epsilon 0 by D, then subtract the thickness of all those slabs and then add a factor, that is thickness divided by its dielectric constant K. So suppose if we are using a dielectric slab which is completely filled between the two plates of the capacitor, then the equation C dash is equal to actual equation A epsilon 0 by D minus, we have to subtract the thickness. Here the thickness D is equal to D, so that is D minus D, then plus the factor D by K. Okay, so that is equal to K times A epsilon 0 by D. Okay, so the actual equation C is equal to A epsilon 0 divided by D. If we are introducing a slab of thickness T and a dielectric constant K, we have to first subtract that thickness T from D, then add a term, the factor, that is displacement, that thickness divided by this dielectric constant. Okay, so for a capacitor, we know we are using these capacitors to store electric charges. When we are introducing a dielectric constant, if it is fully filled between the gap, dielectric constant, if it is K, then the capacitance becomes K times that of the actual capacitor. Okay.